To ACM at UC's sixth general body meeting of the semester. Sign in and attendance right there. I'll mention it a couple more times, but that is important for something coming later in the meeting. So ACM at UC, we are recording this meeting. It's being live streamed to YouTube. So this, along with other resources like our slides that we're sharing right now, will be available on our website at the archive, linked there. So what is ACM at UC? If you've attended some of the other meetings of ours or some of our socials, you know by now we're the student chapter of the Association for Computing Machinery here at UC. It's basically the computer science and programming community. And we have a great group of students built around a common interest in computing, technology, software, all of that good stuff. And we have talks like what we're at right now, workshops, hackathons, and much more. And we're open to all majors. So like always, our code of conduct applies here in our Slack, in our Discord, and it basically just says we are dedicated to a harassment-free experience for everyone. Be cool. Just, you know, it's a focus on learning, not on, well, actually, and you know, stuff like that. So just keep it cool and have fun. All right, so events. We've got some time left here in the semester. So we'll try to have one more social event. Those have been going great so far. And our next meeting is in the spring semester, since from here on out, it's like we got Thanksgiving and then exams. So you guys are all busy here at the end of the semester. So we'll see you at the beginning of spring semester. And then office hours will continue for the rest of the semester with Tuesdays and Thursdays, 12 p.m. and 8 p.m. And you can just come and hang out on the Discord, talk about whatever, share some projects you're working on, do some homework, whatever you really want. And like I mentioned earlier, if you haven't already, check in to attendance at acm@uc.org/c, because since we can't have pizza in person like we usually do, and we're in this virtual meeting, we still want to give back to you guys. So we've been raffling off gift cards at the end of meetings for people who sign in at the attendance. So do that and then stay tuned till the end of the meeting and we'll raffle it off. And we want to give a quick shout out to Revolution UC, our spring hackathon. It's returning for spring 2021, 24 hours of coding, learning, and fun. We've had 300 plus attendees in the past, and this year it is virtual. We've already got some great sponsors lined up, and the organizing team is hard at work making this virtual experience a great one. So you can see updates on our website, revolutionuc.com, or on our Twitter or Instagram. And so Slack is our main form of communication. If you haven't already, join the Slack at that link in the middle there. We have all kinds of different channels for different types of discussion about tech or non-tech that people want to have. And there's desktop and mobile apps. And like I said, the code of conduct applies. Our Discord, we've got started this semester. We've been having some great social events, and similar to Slack, we've got some different channels for various topics and stuff like that. So please join. And in addition to socials, we have our office hours, which will be right after this meeting at 8 p.m. So come and hang out with us after the meeting. And with that, I'd like to bring in, or he's already in, sorry. Our guest speaker for today is Daniel Loscher from LCS, London Computer Systems, and he's going to give us an awesome talk on full stack development, a real life scenario. Thank you so much for being here.
Oh yeah, no problem. Hey guys, my name is Daniel Loscher. I am a software developer at London Computer Systems, and I work with Daniel Hackney. He's a co-op with us there, and he's a team player. So glad to work with him. So today, what I'm going to talk to you guys about is just kind of how everything that you guys are probably learning in your classes, all the different languages, all the different things about data, how they kind of come together in a real world application. So we're going to talk about, let me see if I can get the slide up. So we're going to talk about one of the main products that the London Computer Systems LCS works on, which is called Rent Manager. And Rent Manager is more than just one sort of website. It's a suite of solutions that help property managers, real estate developers, and things like that manage all of the aspects of managing their properties. So one of the things that stand out about Rent Manager is that it is very customizable to your specific needs. So it can handle everything from somebody reporting a broken pipe in one of the rooms, say in the dorm room, to like processing payments, etc., etc. So one of the solutions that the Rent Manager suite has is called RM Express, and this is a web-based solution that runs a website, kind of like your bank. I mean, you guys probably know, but if you go to a URL and you can do anything in there online. And so users will sign up with Rent Manager, and they will have access to the Rent Manager Express. They have a specific URL that's kind of tailored to their specific company. And then once they log in there, just the username, password type of thing, they can access everything to manage everything in the properties. So what is full stack development? So in this particular context, it's referred to like the software stack. So things that basically stack up onto each other to make the whole solution work. So in the full stack, it refers to the stack that forms the elements of any user interface application that manipulates data. So the easiest way to kind of see the stack is to follow the data flow. So from the data source, which could be a database or a file in a computer or a repository or whatever, all the way up to where you can actually interact with the data, or a program can interact with that data, and then does whatever it needs to do, manipulate the data, and then it goes all the way down to the data storage. So here's the basics of like a web application, like a very overview of just in general how it kind of works. In general, like if you guys are probably familiar with how web applications work, you have like the client side, which is your computer, your tablet, your phone, anything that you actually interact with. And then you have the server side, or the cloud, which is basically the internet where everything is stored. And now the cloud could be, it's a very open definition. It could be just one server, or it could be like a host of servers, like Amazon Web Services and things like that. But in general, the way that internet applications are divided is you have the client side, which consumes and interacts with the user interface, and then the backside, which handles all the data storage and data manipulation. So you see here from this from the slide, the way the Web Manager works is you have a user interface, which is a web or browser application. And I kind of put in there because you've probably been learning about HTML and JavaScript and Java and all these other languages, and it's kind of interesting seeing how they actually all kind of talk to each other on like this full stack. So on the user interface, I say programming scripting languages because the JavaScript it's kind of a programming language, but it's really a script library, and HTML, the hypertext markup language, and CSS, the styles. Those are the languages that a web browser understands. So the way you kind of program the user interface would be either through the HTML and JavaScript, or you use develop JavaScript frameworks. So you have Angular framework and React, and then also you can use libraries like jQuery and all these things to do. They're basically extensions of the JavaScript. They're just add-ons on that in things. So if you see there, then you have the layer in between, which is the internet layer, which is all of the things you probably know, the network and all that. And the way the data communicates at this higher level is through the HTTP protocol, which is like any other browser application. So, and then that data gets received by the server or some in the cloud through usually some sort of, in this case, through an application programming interface or API. And the way you can program an API or anything on server side, like you see here, are through languages like Java or Python or PHP or C Sharp and et cetera, that are server based, or you can say the back end, what they call. And then they communicate that with some sort of data source. So in the case of Rent Manager, we use what they call a relational database. So I'm not going to get into too much detail unless you guys want me to explain a little bit more what relational databases are. But it's basically a way of storing data in form of tables that have certain fields in those tables, like columns on those tables that they're called fields, and then they can relate to each other. And then data is kind of like combining all these tables to get you all the information you might need. So one of the ways that you can use programming language slash scripting, more or less, is if you're using a relational database, you have MySQL or SQL Server, or on the non-relational databases, you might have the MongoDB and all the other things that where data is not necessarily stored in a table format. So do you guys follow me so far? Do you guys have any questions you want to ask before I go on? Okay, no comments in there yet. Just feel free to stop me at any time and ask any question. You chime in or write it in the comment section here, and I'll try to get to you. All right, so let's continue on. So the RM Express web application is in its essence a CRUD application, which means CRUD stands for create, read, update, delete. This is, again, like I was saying earlier, it's in relation to data. So everything is how data flows. So that's what it is at its base. So what the application relies on a relational database as the data storage. And the data is manipulated by the API and is sent. It's converted and sent via HTTP to the user interface. Now, the user interface communicates the data to the server via the particular commands or requests with HTTP, which are the post, the get, and the delete methods or requests. So, in a nutshell, the way you get data or send data down to a server from a web application is through specific methods. So you say, I want to post this data. So this is kind of self-explanatory. Post means that I have this data, I want to send it out and post it or put it on a server somewhere. And when you say get, it's, hey, I want to get data from you from the server, from the cloud. And delete is pretty self-explanatory. Say, I have this data that I want to remove from the server. So far, so good. No questions. Most people, you guys might be too smart. That's good. All right, so we'll continue on. All right, so here's kind of the flow of data in a web application when you implement the full stack. So you can see from the top, you can start it from either way, but let's just say when you initially go into the URL, you put in the Rent Manager URL, you're sending a request to the server, either a GET or probably an initial GET request. Hey, give me some information so I can display things. So the data starts from the user interface, which in this case is the web application using the Angular framework, the JavaScript framework. That talks to another, it's still considered a user interface, which is called the web application interface, which is the web API, which we'll get into a little more detail, but it's essentially still considered a user interface, even though it's not as nice with GUI, but it still relies on when you sending an actual request and presenting the data in, we'll get into this more, but in a format called JSON or JavaScript object notation. So that's still considered a user interface. So then that, when it gets that requirement interface, and that's where the business logic is. And we'll get more into this, but the business logic has all the specific rules for the specific case that you're using to handle the data conditions, like, oh, I require this information, you need certain privileges to delete or add or update this information, etc. And then the data access, which is inside the application program and interface, which will take those that data that's coming in and kind of convert it. In this case, it will convert it to SQL statements that will be inserted into the database. And then once that database, our DBMS or the relational database management system has everything done and it puts the data in the table however it needs to based on the query, it'll say, hey, here we go, the result is successful or failed or whatever it is. And then it'll send that data back right up, climb up the stack again until you get a response in the user interface. And in this case, let's say you were saving something with your tenants. Like, I don't know, you added the tenant to a unit or like a dorm. And you fill out the form and you hit add tenant, and it goes through all this process. And then once it's saved, it comes back as success, and then the application says tenant is added successfully. For example, that's how you would know that the data went that full circle. Any questions so far? All right. Okay, we continue on. So the web application, the web browser application, this is the first part of what we're talking about, the user interface. So a web application, in the case of the RM Express, was developed using the IDE, which I'm sure you're familiar with, which is basically like a tool you use to create code. So like Eclipse if you're doing Java, or Visual Studio. And in this case, we use one called Visual Code, which is from the same family as Visual Studio, but it's designed to work well with Angular frameworks or TypeScript and things like that. So we use that, and you create everything related to the web application part. So like we were saying, like I was saying earlier, it is based on JavaScript / TypeScript, which is basically added onto JavaScript, and HTML and CSS, because again, the browser only understands those languages. So the framework that we use for JavaScript is called Angular, and the important thing when you develop applications and things is to try to make things as decoupled or as independent as they can be, because if you develop, in this case, a UI, web application, using Angular and all that, and it works, and then the only thing it needs to work with the database server is just a way to send out those HTTP requests. And it allows you to, in the future, instead of say you're using Visual Studio, C# and all that, and Microsoft .NET Core and all that on your backend, but then you decide you want to redo everything and do it in PHP and Angular, and then do it in Amazon Web Service. You can do that, because as long as at the end they still talk to each other with the JSON models and HTTP, then everything you develop on the website, will work, or it should theoretically work. So the idea of having it decoupled. So that's how we've developed this part, is you get all of the elements on the UI, and you make sure that they are separate from what that they can work independent from the backend. So far, so good. No questions? Okay. If I'm throwing too much stuff at you, you guys let me know. You can slow down. All right. So continuing on how more or less we do this. So Angular breaks the user interface pages or elements into what we call components. That's kind of like the framework of how Angular kind of works. They call them components. And what essentially they do is that they are parts that when they work together, they complete the UI puzzle. So some of these modular components have specific jobs. They can be very small, like or very large, like either rendering a view and showing you a bunch of stuff, or as simple as handling the styling on a button, or handling a particular um, function that's going to send data to some other component or down to a service or something. So in this case, like I said, some components will handle the communication with the HTTP through services and things like that, and say, okay, we'll get all this data, churn it up, make sure that I put it in a JSON model and send it via HTTP either through a post, get, or delete request. So how does this work with the web API? So this is what I was telling you earlier, that it's like, well, it's kind of a UI, but it's not really as pretty as if you had it on a graphical interface. So to interface with a web API, you use the same protocols, the HTTP, post, get, and delete. And what you do is you can send what we call RESTful requests, or use a newer technology, which is GraphQL, which was developed by Facebook. So, and not to get into too much detail on this, because all of these you can go in and very, an entire discussion we can go on just REST APIs and or graphical. But in general, when you're sending data from the web server or receiving it to the backend, the data is structured in what they call, we're saying, a JSON, or JavaScript object notation. So you guys probably, some of you might already be familiar with the idea of object-oriented programming, which is how everything that you see when you program is created into an existing object. So like a person would be an object, a user or a tenant or an apartment or a car, anything, you can create objects like that. And then you can, these objects have properties and methods and actions that they can do. And in general, not to get too much into object-oriented programming, there's the idea of inheritance and polymorphism, et cetera. But for this part so far, is the object is formatted in a plain text form, which I'll show you next. So it's you represent the object as a string, right? Which is like all of that you see there, even with the curly braces, there are basically a string that will encapsulate all the properties in the object. So in this case, this is a simple example of a logging object. So you might have more information, less information, but let's say that for the very basic, you need username and password. So you're going to send that object down when you log in, right? When you initially get the request back from the server, say, hey, here's a login page, provide me your username and password. And once that's rendered from the UI and it's going to be sent down through the web API, it might be sent out through a post request with this as part of the body of that request. So that's what the JSON is. And then the server will take that and do the rest and grant you or deny you access or whatever. So, all right, give me one second. Sorry about that. Okay, so the user interface, the different interfaces, which is in this case is the web API and the web app, they follow what we call the MVC, or model view controller pattern. So not, again, this is a concept that we can have an entire conversation on. But like a slow overview is, you have the idea of a model, which is kind of what I showed you before, which is the data structure or the object. So an example could be a user object that has first name, last name, user ID, age, or whatnot. And in general, sometimes those objects can be direct relations, in the case of a relational database, to a table. So like user table will have all these different fields, and those are the properties that would comprise the object. So you can think of a dog as an object. You say, well, the dog has the properties of color, breed, size, et cetera, et cetera. And so then the idea of a view is the interface used to manipulate or the model. So it's kind of how it shows the end result of that model. It could be on a nice, awesome view that you can have buttons and screens or video or whatnot, or it could be just as simple as a plain text JSON object, kind of like I showed you before. So that's why the way that the web app works is it consumes the web API's user interface, which is the result, which is the JSON model. And then it takes that and uses that to do a thing, to show it to you nicely on the screen. And the controller is kind of like the marshal. So it's between the view and the model. So it handles everything related to dispatching the information to build the models and to send it to the appropriate views for rendering or showing. So, okay, so going down a little layer after the user interface, so after the request from the user gets sent in, or from the web application gets sent as a JSON model to the web API, the web API will then kind of convert the JSON, that object notation model, into the specific model that's developed for that particular API's programming language. So in the case of a C# model, we just have very similar, like in the case of the username, it'll have the user model, and it'll have the way that you define a model in an object in C# is by saying, like, and instead of, like, for example, username, that's a string username, the type of the variable in that property would be a string for username, or int for ID, etc. And it'll convert that to that particular language, and then it'll send it for further processing. So the web API has controllers, like we were saying, controllers are that kind of that marshal, and it listens, quote unquote, to the request coming in, either through REST request, which is basically you type in a URL, like let's say for the case of tenants, you go the URL rentmanagerexpress.com/ and you say tenants. And you send that as a GET request. So that URL is telling the web API, hey, call this particular controller that is called literally tenants. And you say, okay, somebody's giving me a request for tenants. I'm going to go and marshal this request to the appropriate place in the application to go and process it further to get the tenants. So the controllers are kind of listening for those requests, and then they push it down the stack for further processing. So on the web API, once it's converted and dispatched the data, the API will take the data request, and before continuing it further, it'll check to see if it follows the business rules for the specific application. So this is kind of how we have an overall overview of how we have it. So we have this business logic that has specific rules that are going to take that data that's being converted and make sure that whatever's being passed down meets the specific rule. So an example would be an access privilege to specific data. So let's say you were to log in and you successfully log in, but your user doesn't have access to get all the tenants, for example, in the case of the rent manager. You all of a sudden go into the app somewhere and click tenants, and then it goes in the back end and renders everything and sends up that REST request down here that says /tenants. And then once that model is there and the API looks at where the request is coming from, etc., and determines that you don't have privileges, it'll stop there and say, hey, send this response back to that user, say you don't have privileges, and then that goes back up the stack, and then the way the user interface will take that response, that data coming back, and say, hey, you don't have privileges. So if there's an error, you send an error object as a JSON, kind of like what you saw for the user, and then that will be consumed and say, hey, error, you don't have access for that, etc. Assuming that everything's good to go and then the business rules are met based on what you've originally sent, then it's pushed down to the lower layer of the API, which is the data access layer. So far, so good. Hey guys, any questions? Have I lost you so far? Let me go back on something. All right, so continue on. So once the business logic, like I said, it's made its checks and it goes to the data layer, it will convert that to the specific queries or languages needed for the data manipulation. So in the case of RM Express, we use, like we're saying, our relational database. So it will create, it'll actually have an engine there we have to create the actual queries to actually do the read, create, update, and delete operations on the data in the database. Other ways you could use manipulation of data would be to call and store procedures, which are basically things you program on the database side, and they're basically, again, objects. And you say, hey, let's say there was one for tenants, this is get tenants, and all of a sudden, once all the data gets down to the data layer, you call that query, that store procedure, that's called get tenants, and you pass in, say, a number, an ID, or no ID, and it will give you everything. So it'll give you a specific tenant or all the tenants. And so, but in our case, we usually have a program data access engine that will take all these requests, build it up, and create the query script, and then send that to the database management system, and then it'll do its magic, and then you say, okay, here we go. Here's all the tenants. All right. So here's how it kind of goes. So after the full queries are executed, the process, like we showed earlier, is reversed. The data access will convert the query results into the specific models of the API, which is specific programming language API. And then once it reaches the web API controller again, it'll convert that into the JSON object again, which is, again, that's the UI part of it. Send it back via an HTTP response. Now you can consume that HTTP response either through a third-party tool. One of them is like Fiddler or Postman, which is you can actually send the REST request, and then you put it in, and you get the response back as just that JSON that string object, or that string object is further consumed and displayed nicely on the UI. So it'll render that model, and it'll put it in the view again. The idea of the model view controller kind of structure. So, you guys have any questions? You guys want me to go over something else? I'm open. That's what I got so far.
Yeah, that's a really good summary of the whole stack. I like that. I just wanted to mention, I feel like for people hearing the model view controller for the first time, I know when I first heard about that, I was a little bit confused. But I will say that it sounds like super specific to maybe a certain platform or something, but it is a pretty widely used theory of like how to split your logic in an app. Like I know if you're developing iOS apps, they also use that logic. So I feel like once you understand that that way of splitting your logic, you can learn other platforms or languages that use it pretty easily.
Yeah. So the idea of having everything done in that manner is like back in the old days, you used to develop pages as like or ASP or active server page, which would mean that you would have to render everything, and every page was stored separately on a server. Whenever you went in and sent a request, it would just get that whole page and render it out. And that tends to be kind of heavy when you're dealing with large applications. So the idea of the model view controller is you're only manipulating or sending the data that you really need, and you're not having to have each individual page stored as a file. And you can just say, hey, I don't want you to render the whole UI. I'm just changing this particular part, and give me the data. That's all I want to send through the wire. It's just a JSON model. And the the idea of that's kind of where it's useful. It makes everything so much faster. And everything with Angular and any web application nowadays, like you were saying, it's all going to be on that pattern of MVC.
Awesome. Yeah. Well, if anyone else watching the live stream has any questions, you can throw it in the live chat or and we'll answer them. I guess another question I can ask is at LCS, how often, or I guess what would be the split of how often you're working in each of these different layers of the stack, like front end, back end, and database?
Well, and the good thing about LCS is and specifically in the team that Daniel and I work in, is we're starting a new application from scratch, and we've
Cool.
had a bunch of lessons from the different other suites and things that they've developed. So we work in all of it. We would develop. We sometimes have a lot of the SQL stuff that's kind of already done, but we still do need to do database updates. So you have to know how to write all the queries and maybe find mostly to manipulate tables and things like that. But we do the whole thing like every day. Like today I did SQL, and then I did Angular, and then I did the C# part of it. So I did everything. So it's kind of like that every day.
Awesome. Is Daniel in the backstage area? Can we bring him out, or is he not there?
Yeah, what up?
Hey.
Yeah, I was also going to comment, like, the particular team that we are on is we very much do everything full stack. So, like, even today, and even just being an intern, I was in all three things. I had to write a lot of database updates, and then I had to do some C# stuff and some Angular stuff, and HTML and like stuff on the front end. So it's definitely true. Like everything that was in the presentation is stuff that we do every day.
Awesome. For both of you guys, is there a part of it that you enjoy the most, or what's the part of your job that you enjoy the most?
You want to go first?
Sure. I mean, I enjoy the whole thing because I like seeing how everything kind of comes together. I mean, I'm not an expert in any particular area by any means, but the idea of being siloed is what whenever like our team lead says, don't get stuck in a silo in one area only. Is that you can see everything, and then how it actually has a real impact. I think the idea of making it all work together is what I like the best.
Yeah, I would say as a co-op, it's nice that although I'm working in all pieces of the software, which at first was very intimidating because you feel like you need to understand everything. You need to understand the back end, the front end, the database, all of it, and I don't even now. Like it doesn't all just come together like that, but it works together in a way that I don't need to know everything about the back end to know how it can be used to like provide information to the front end. So I can just I can take it piece by piece and just trust that the people who did work on the back end and the people who did work on the front end knew what they were doing, and everything just kind of comes together. And so I can kind of just hop on board and figure things out as I go. And that's really been nice.
Yeah, part of it, that's the idea of like when you program in general, even if it's just a microcontroller, it doesn't have to be a web application. Is the idea of having everything that you do be as decoupled as it could be, which means that even when you create a single method on something, make sure that method can run on its own, and then it just has to have some inputs, and then whoever uses that method or from a single thing as a method, all the way to or a function, all the way to an entire backend, is that the person that's going to use that or the program doesn't need to know anything about the inside. So the idea is you develop things that are decoupled, that don't necessarily depend on each other for them to get to work. So like I was saying, is that you can create. If Daniel was brought in the group to do the UI stuff, and then one day we had it all on PHP, or then we decided to do C#, and he didn't know. He just knows hey, whatever. I just get this JSON model and I do what I do on the UI. Yeah. You wouldn't have to know anything that happens in the back end. Or if the other way too, I'm creating a JSON model. I don't know who's going to consume it, how or where. That's not my concern. I'm doing it in PHP or C#. I'm focusing on this. And same thing all the way down to the data access. Creating queries, you say, here's your data. I don't know how are you using it, but here's how we're going to write it. So that's the idea of having everything separate.
Awesome. Well, I don't see any other questions in the chat right now. If anyone has anything else, real quick, you can throw it in. But anything else either you guys want to talk about, or I think that's all the questions I had. All right. Well, thank you again so much for being here and sharing all that great information with us. And I hope everyone has a better idea of the kind of high level concepts of what all needs to come together to build great apps.
Thanks, Daniel.
Yeah.
Yeah, thank you so much. Yep. All right, so I guess with that, we can head on over to our raffle. So let's bring on Kevin. Hello.
Hey. Oh, hello. Can you hear me?
Yep, you're good. Yep.
Awesome. Okay, so let's just give people a little bit. Go ahead and click on the, or not click on, but go to www.acm@uc.org/c. It's in the chat on, so you should be able to copy that if you haven't already gone over there. We'll give people a little bit to go ahead and do that.
So I saw you're going to be co-oping with LCS soon, huh?
I'm going to be co-oping with LCS. Yeah, so this is very interesting to.
Yeah, it's a sneak peek.
Yeah, this is going to be my first co-op, so I'm probably not going to be doing the stuff that he was talking about that much, but next time maybe, right?
Yeah.
So,
cool.
Yeah. Okay. So how do I share my screen? Do I just click?
Yeah, share it, and then Piyush has to click over to it. Take away my screen.
Can I do that? Oh. Can you?
Yeah, there we go.
Okay. Awesome. So we got a cool wheel now. So. All right. So.
All right, Trent.
Woo! Congrats. Just go ahead and you can either put an email in the YouTube comment thing right there, or you can send me something on Slack. Just if you @Kevin Sly, you should be able to find my name or whatever. You should be able to just send me an email that you want an Amazon gift card sent to. We'll do another one as well. And Aaron, same thing goes for you. So thanks everyone for coming, and
Yeah, thanks.
I'm still sharing my screen. I don't know what's up. Okay. Okay. So
Okay,
there.
that email down there.
Yeah. Awesome.
Awesome. All right. Well, I think that's all I've got. Yeah, the last slide just says thanks for coming, and fill out attendance if you didn't already, but now it's a little late for the raffle. So, but thanks all for coming, and I hope you learned a little bit. And we'll see you hopefully at the next social. Check Slack and Discord for, we'll try and figure out a time and an event that we're going to do. We've played some great games in the past. We'll see what we can get set up for this time. So thanks again. And right after this at 8 o'clock, you can hop into the Discord and we'll be hanging out for office hours. Thanks again. Have a good night.